Chapter next, oscillation. Oscillation is also called vibration. अगोदरच्या वर्गामध्ये 11वी मध्ये 10वी मध्ये आपण ऑसिलेशन त्याचप्रमाणे व्हॉट इज मीन बाय एम्प्लिट्यूड, व्हॉट इज मीन बाय फ्रिक्वेन्सी, व्हॉट इज मीन बाय डिस्प्लेसमेंट, व्हॉट इज मीन बाय पिरियड ह्याच्या टर्म आहे त्या व्याख्या आपण शिकलेलो. एम्प्लिट्यूड मीन्स द मॅक्सिमम डिस्प्लेसमेंट ऑफ बॉडी और पार्टिकल फ्रॉम इट्स मेन पोजिशन. फ्रिक्वेन्सी द नंबर ऑफ ऑसिलेशंस और नंबर ऑफ वाइब्रेशन परफॉर्म बाय द पार्टिकल इज कॉल्ड फ्रिक्वेन्सी. Displacement will change the position of particle. Period, or it is also called periodic time, is nothing but the time taken to complete one oscillation or time taken to complete one vibration by the particle is called period or periodic time. Suppose we consider the example of simple pendulum. This pendulum is oscillate to and fro again and again in same path and same interval of time. Also the vibration of spring, if we apply the external force, the spring is moved up and down again and again in same path. Simple pendulum oscillation मागं पुढं होतं. ह्याचे this is the mean position and this distance is called amplitude. This is the maximum displacement of mean position. This is the mean position. हिला आपण mean position म्हणतो आणि हे असे extreme position, positive extreme position आणि हे negative extreme position. Oscillation, we define the oscillation. Oscillation is nothing but the set of particle move to and fro, up and down, again and again in same path. Such movement of particle is called oscillations or vibration of the particle. And also we define the term that is periodic motion. The time taken to complete one oscillation of the particle or by the particle is called period or periodic time. And then motion of body is to and fro or up and down in regular interval of time. That motion is called periodic motion. Now we define the linear simple harmonic motion. Linear simple harmonic motion. त्यामध्ये शॉर्ट मध्ये SHM simple harmonic motion असं. आता firstly we define the linear simple harmonic motion. Definition: the periodic motion of body, the periodic motion of body in which acceleration or force is directed towards mean position and magnitude of force or acceleration is directly proportional to displacement of the body. It's called, such a motion is called linear simple harmonic motion. In short, it is called SHM, linear SHM. The periodic motion of body in which the force or acceleration is directed towards the mean position and its magnitude of acceleration or magnitude of force is directly proportional to displacement of body is called the linear simple harmonic motion or linear SHM. Now आपण आता 2 मार्काचा प्रश्न बघू की डिफरन्शियल इक्वेशन अनेक वेळा विचारलेला आहे पहा. डिफरन्शियल इक्वेशन ऑफ linear simple harmonic motion. According to definition, the magnitude of force is directly proportional to the displacement of the body, or F is equal to minus kx, where this minus sign indicates that force and displacement F and x are opposite in direction, and this k is constant, and that constant is called force constant. This k is called force constant, and this is given as k is equal to minus F upon x, and where this k is called force constant. Now, from definition, we prove F is equal to minus kx, and according to Newton's second law, F is equal to ma, where m means mass, a means acceleration. According to Newton's second law of motion, from these two equations, it is clear that minus kx is equal to ma. Say equation number 1. Minus k. If we compare this equation, f is equal to minus kx and f is equal to ma, we get minus kx is equal to ma. Say equation number 1. Now we define the velocity is nothing but dx upon dt, and acceleration a is nothing but dv upon dx. dv upon dt. V means velocity, dx upon displacement upon time. Acceleration means velocity upon time. Therefore, a is equal to d upon dt. We use values of v, that is dx upon dt. Or this gives acceleration a is equal to d square x upon dt square. Put the value of acceleration in equation 1, we get minus kx is equal to m into d square x upon dt square. Rearrange the term, that is m d square x upon dt square plus kx is equal to 0. Divided by m, we get d2x upon dt square plus k upon m into x is equal to 0. This is called the differential equation of linear simple harmonic motion, or put omega square is equal to k upon m, where omega is nothing but angular frequency. Therefore, this equation becomes d square x upon dt square plus omega square x is equal to 0. And this equation is called the differential equation of simple harmonic motion. 2 मार्कासाठी आपण हा परीक्षेला विचारलं जातं पहा की डेफिनेशन पासून सुरुवात करायची. f इज डायरेक्टली प्रोपोर्शनल टू x पासून आपण कुठपर्यंत आलो d square x upon dt square plus omega square x is equal to 0. This is called the differential equation of linear simple harmonic motion. Now another topic, that is we calculate the acceleration. We calculate acceleration, velocity and displacement in SHM. What is the formula of acceleration? What is the formula of velocity? What is the formula of displacement in case of simple harmonic motion? Now, using differential equation of simple harmonic motion, that is d square x upon dt square plus omega square x is equal to 0. Therefore, d square x upon dt square is equal to minus omega square x. But we know that the d square x upon dt square is nothing but acceleration, and acceleration is denoted as a. Therefore, a is equal to minus omega square x. This equation gives the acceleration in simple harmonic motion. This is the first, is we calculate the acceleration in simple harmonic motion. Secondly, we calculate the derivation of velocity. Now, we get d2 square d square x upon dt square is equal to minus omega square x, or this can be written as this is the acceleration d square x upon dt square, and acceleration this can be written as in the form of velocity, that is dv upon dt is nothing but acceleration. This is equal to minus omega square x, because this can be written as acceleration a is equal to minus omega square x, and acceleration, definition of acceleration is dv upon dt is equal to minus omega square x. Now we multiply dx, we get dv multiply and divide by dx, dv upon dx, dx upon dt. पण काय केलं, dv upon dt या टर्मला dx ने मल्टिप्लाय केला आणि dx ने डिवाइड केला. म्हणजे dx कॅन्सल होईल, मग आपल्याला मिळेल dv अपॉन dt. फक्त आपण ती टर्म रिअरेंज केली. dv अपॉन dx अपॉन dt इज इक्वल टू मायनस ओमेगा स्क्वेअर x. dv upon dx as it is, but dx upon dt is nothing but velocity, or this is equal to minus omega square x. Therefore v into dv, dx ikkada give upon minus omega square x into dx. Now take the integration of both sides. Integration v dv is equal to integration minus omega square x into x. The solution of that integration is v square upon 2, which is equal to minus omega square is constant, x square upon 2 plus c, where c is the constant of integration. So equation number 1, that is v square upon 2 is equal to minus omega square x square upon 2 plus c, where c is constant of integration. Now we apply the condition if the displacement of particle is maximum, that is plus minus a, then this is the extreme position. When displacement is maximum, that position is called extreme position. The extreme position displacement is plus minus a. Then at that position the velocity is 0. Now put these two conditions in equation 1. We get 0 upon 2 minus omega square a square upon 2 plus c. Therefore this is 0. Then we get value of c is omega square a square upon, put this value of c in equation 1, we get v square upon 2, which is equal to minus omega square x square upon 2 plus c, that is omega square a square upon. Now 2 common cancel. Therefore v square is equal to omega square a square minus omega square x. V square is equal to omega square is common into bracket a square minus x square, taking square root of both sides. Therefore v is equal to plus minus omega under root a square minus x square. Suppose this is equation 2, or this bracket equation is called the velocity in simple harmonic motion. This is a is equal to minus omega square x, acceleration in HHM, and v is equal to plus minus omega into bracket a square minus x square. This equation is called the equation of velocity in simple harmonic motion. Now we calculate the displacement in simple harmonic motion. The equation of velocity is v is equal to omega under root a square minus x square. This is the velocity. Now using the definition of velocity, that is dx upon dt, nothing but velocity, is equal to omega under root a square minus x square. A square root ikkada dt palikadu. Therefore dx upon under root a square minus x square is equal to omega into dt. Taking integration of both sides, we get integration dx upon a square minus x square, which is equal to omega constant integration of This is the standard formula, that is sine inverse x upon a. This is equal to omega t plus phi, where phi is constant of integration. Therefore, x upon a is equal to sine omega t plus phi, or finally x is equal to a sine omega t plus phi, and this equation is called general equation of displacement in simple harmonic motion. Now, case first, at mean position, the displacement is x is equal to a sine omega t. At mean position, this is the general expression of displacement, that is x is equal to a sine into bracket omega t plus phi. But first case, at mean position, this equation change, x is equal to a sine omega t, and case second, at extreme position, the displacement is equal to a cos omega. This is the second case, that is at extreme position, the displacement of particle will be x is equal to a cos omega t. This is the acceleration, velocity and displacement in simple harmonic motion. Now we add one more small topic, that is what is the values of displacement, velocity and acceleration in mean position or extreme position in simple harmonic motion. Firstly, at mean position, the first is, what is the value of displacement? At mean position, what is the value of displacement? The displacement denoted as x, or x is equal to 0. So at mean position, displacement is 0. Second, that is b. What is the value of velocity? That is phi is equal to a omega under root a square minus x square. Now put x is equal to 0, that is phi is equal to omega under root a square minus 0, or phi is equal to omega a, or v is equal to plus minus a omega. This is the value of velocity at mean position. And C, that is what is the acceleration a in at mean position. The acceleration is equal to minus omega square x. Put x is equal to 0, therefore a is equal to 0. At mean position, displacement is 0, but velocity is maximum, that is plus minus a omega, plus mean in positive direction, minus mean in negative direction. The displacement is 0, velocity is maximum, but acceleration is minimum. That is at mean position, displacement is minimum, velocity is maximum, and acceleration is minimum. Now, case second, at extreme position, what is the value of displacement, velocity and acceleration? Firstly, a displacement x is equal to a. Now one sometime you can write plus minus a. Consider only magnitude. X is equal to a. That is, this is the maximum value of displacement. B. What is the value of velocity? Phi is equal to omega under root a square minus x square. Put x is equal to a. Therefore, phi is equal to omega under root a square minus s square. Phi is equal to omega into 0 or v is equal to 0. At extreme position, the value of velocity is 0, that is minimum, and the value of acceleration minus omega square x. X is equal to a, therefore a is equal to minus omega square into a, or a is equal to minus a omega square. This is the value of acceleration at extreme position. We determine the values of displacement, acceleration and velocity at mean position and at extreme position.